Acidification, a story of created bonds, lost bonds, and a tale of self-acceptance and destruction. Meet the elements: hydrogen ions, carbon dioxide, carbonic acid, bicarbonate, carbonate, water. Act 1. Atmospheric carbon dioxide dissolves into ocean water. It then bonds with water to create carbonic acid. Carbonic acid reacts further in water to create water, hydrogen ions, and bicarbonate. Reactions keep happening. Bicarbonate says goodbye to its hydrogen ion, becoming carbonate ions, leaving hydrogen ions all by themselves. Through these separations and other bonds made throughout this cycle, carbonate finds itself on its way to self-acceptance while lowering the pH of ocean water worldwide.
Act 2. The experiment. The experiment calls for a small cup full of salt water. There's also pH paper. The pH paper shown that has already been tested out extra CO2. The center of the paper depicts what pH it is, and originally it seems to be around 5. I am now going to blow CO2 into the water to try to lower the pH. I blew into it for 5 minutes, and now I'm going to test the water again with a new strip of paper. The center of the strip will show what the new pH will be. Just going to slip it in there. This yellow mark in the center changes color and determines the pH with the reference color. Here are 4 strips of pH after about 5 minutes, 3 minutes, and 1 minute. In the 13th minute, the pH lowered from around 5 to around 4. This experiment was to show how adding CO2 to salt water can lower the pH in such a drastic way in a short amount of time. Act 3. The Long Island Sound and Biota Effects. The Long Island Sound on Connecticut's shoreline is of great concern lately. Fishermen and fishery companies are concerned about how acidic the water in the Long Island Sound is getting. They are concerned especially for shellfish. As seas become more acidic, they become inhospitable to some sea life. Rising acidity robs seawater of carbonate ions, an essential ingredient used by creatures like shellfish and corals to build their shells. On the extreme end, if seawater becomes acidic enough, shells literally dissolve, which can be disastrous for survival. We know that some creatures, corals, clams, oysters, scallops, and some forms of plankton, are sensitive to these chemical changes. More research is needed to fully understand how declines in sensitive species could ripple across the food web and cause harm to commercial finfish. Act 4. What you can do to help.
Participate in beach cleanups to reduce the flow of trash into the ocean. Reduce your carbon footprint and the amount of carbon you emit into the atmosphere. Walk, bike, carpool, or take the bus. Use non-toxic cleaning products. Use less fertilizer. Fertilizers add nutrients to the soil and water that can be carried downstream when it rains. Extra nutrients can cause algae blooms that can disrupt the ocean's natural balance.
In conclusion, ocean acidification is a global concern, but more importantly, hits close to home here in Connecticut. Not only does it threaten oceanic species, but can also harm us in non-direct ways, such as a drop in tourism, a decline in fishery occupations, and therefore our economy. But don't worry too much. Connecticut, as well as the whole nation, is working to try to decrease CO2 emissions, hopefully slowing down the acidification process. Remember, you can help by lowering your carbon footprint and doing exciting things like biking, carpooling, and walking as an alternative means of transport.